First engine arrives for box alarm. Engine 1 firefighter is stretching a rack line. Nozzle firefighter flakes out rack line, is ready for water. Rack line gets charged. Driver is over pumping to 150. Nozzle firefighter is flowing nozzle, so driver can set the pressure, verifies all the kinks are out. Engine 1 driver has deployed his short section of 5-inch and also his manifold and is getting ready to receive supply line. Engine 2 arrives. Their position is behind engine 1. They cannot pull past engine 1 due to the fact that there's a car parked beside engine 1. Ladder 1 arrives behind engine 2, gets the corner of the building, positions for aerial use. Engine 2 driver, engine 1 coordinate, they start nurse pumping. Engine 3 spots at a hydrant and goes out, announces his position. Engine 3 firefighters prepare the hydrant and check it to lay in a 5-inch supply line. Engine 3 firefighter dresses the hydrant with the gate valve on the 2.5 and the threaded adapter on the steamer. Engine 3 lays in 5-inch to the scene, is instructed to connect the 5-inch to engine 1. This aerial view shows how far engine 3 is going to have to hand jack their hose to get to all the way to engine 1. They're going to have to hand jack past ladder 1 and engine 2 to get to the manifold of engine 1. which is a very common scenario. We want the 5-inch connected to engine 1 because engine 1 is fire tack. We want all the water going to engine 1. After engine 1 receives a 5-inch supply, engine 1 and engine 2 driver will coordinate with dual pumping by connecting their 3-inch hose intake to intake on engine 1 and engine 2, so engine 2 can be dedicated RIC and have a residual water supply from engine 1. Once the 5-inch gets charged, firefighters on water supply engine should walk it, make sure all the kinks are out, and then get a static pressure on the manifold if possible, and give that to engine 1 driver. The second option would be for the engine to come around on the back side of the building opposite of where engine 3 went. In this case, it would be engine 4. They have decided to come back on the back side of the building a different main than engine 3, plus they won't be clogged up behind the massive amount of fire trucks on the alpha side of the structure. They'll be checking the hydrant as normal, making sure it's good, dressing the hydrant with a 2.5-inch gate valve, and then laying in a 5-inch. The nice thing about coming from a different direction like this engine did, there's many advantages. First one, of course, being not behind 10 different units on the alpha side. Second one is they get a good look at the Charlie side, the back side, so they can give command a size up or a further size up of conditions. Third advantage would be they're in a good position to supply an aerial on the back side. And also they might have a bigger main than the one on the alpha side being used. If command needs exposure lines, they're in a good position to use their unit and plug in with the water supply and be able to pull exposure lines off of their unit. Good. So now you can see the firefighters pulling off slack so they can take it to the first engine, which is fire tack. Confirm with command which unit is fire tack. We always want to take it to the fire tack engine. So you can see the driver of engine 1 has noticed the line has been laid from a different direction. He's moving his manifold in short section to accommodate that, and they'll be bringing their 5-inch up to make the connection. As you can see, the connection has been made to the manifold. They'll be charging the line soon, and once the line is charged, they'll walk it for kinks. And then same as before, if possible, give a static pressure on the manifold to the first-in driver so he has a true residual on his intake gauge when he's flowing water. There's a top aerial view of the hose laid in, no kinks. They're checking it, and that's the end of the water supply video.